Okay, we are going to graph the quadratic equation written in standard form using the 4-point method. My 4 points that are special on a parabola are the two x-intercepts, the y-intercept, and the vertex. So those are what I'm going to find. My equation is written in standard form. It's y equals x squared plus 2x minus 24. I'm going to start by finding the y-intercept. The y-intercept is what you have when x is 0. So I'm going to plug 0 in for x into my equation, and I would get 0 squared plus 2 times 0 minus 24. That means my y-intercept is negative 24. Over here on my axes, I'm just going to kind of estimate where negative 24 would be, and I'm going to label the point with the ordered pair, 0, negative 24. Next, I'm going to find my x-intercepts. To find the x-intercepts, I need to put 0 in for y. So when I put 0 in for y, I get 0 equals x squared plus 2x minus 24. I can't solve this equation because I have two terms with an x in them. So the only way I can solve them is by changing it to factor form and using the zero product property. So I'm going to factor it. I'm going to use an area model and a diamond. I put the x squared in the bottom left. The 2x goes in the bottom of my diamond. The negative 24 goes in the top right. I multiply these two to get the top of my diamond, negative 24x squared. So I'm looking for two numbers that multiply to a negative 24. That means one is positive and one is negative. I'm going to go through my factors of 24 and see which ones work for me. Since I have a positive and a negative, I'm actually finding the difference of the two numbers, and I want that difference to be 2. So 4 and 6 are going to work. 2 is positive, so I want my positive to be the bigger digits. So 6x and negative 4x. 6 minus 4 gives me 2, so I know I did that right. Now I can put these two back into my area model. It doesn't matter which spot you put them in. And then I can work the outside of my area model to get my dimensions, my factored form, and I would get x plus 6 times x minus 4. Now that's not the solving part, that's just getting it to the point where we can solve. So the zero product property tells us that if I have two things that multiply and equal 0, one of them has to be 0. So I'm going to say, well, what if x plus 6 is the parenthesis that equals 0? Subtract 6 from both sides, and I get x equals negative 6. There's one of my x-intercepts, so I'm going to put that up there, negative 6, 0. Or what if x minus 4 is the one that equals 0? Add 4 to both sides, and I get x equals 4. So there is my other x-intercept. So again, I'm going to come over here to my pair of axes, and I'm going to plug those 2 points in. Negative 6 would be about here, and again, label them with your ordered pair. Positive 4 would be about here, and again, label them with your ordered pair. So now we need to find the vertex. The vertex is always going to be halfway in between your two x-intercepts. So the x value is halfway in between negative 6 and 4. We talked about how you can find that x value by averaging the two numbers. So negative 6 plus 4 divided by 2. Negative 6 plus 4 is negative 2 divided by 2 is negative 1. So the x value of my vertex is going to be negative 1. To find the y value, I just have to plug negative 1 back into my equation. And I can plug it into the factored form, or I could plug it back into the standard form. It's entirely up to you. I'm going to plug it into the standard form. So I'm going to have negative 1 squared plus 2 times negative 1 minus 24. And now when I evaluate this, negative 1 squared is 1, 2 times negative 1 is negative 2, minus 24. That gives me my y value of negative 25. So my vertex is the point negative 1, negative 25. Okay, I'm going to go back to my axes. I'm going to plot that point. Negative 1 would be right about here, and negative 25 is going to be a little bit below negative 24. When you're sketching your parabola, it is not going to be perfect, and that's totally fine. I like to just kind of do one half at a time. Don't forget you have to go beyond the axes and put arrows to show that it keeps going forever.